Hey guys, so here's the notes for 3.2. We're going to be talking about factoring quadratics when a does not equal 1. So in the previous, we basically just saw x squared plus bx plus c. Here, we're actually going to see a value or a coefficient in front of the x squared. And so that is going to change how we're going to factor these quadratics. Okay? Now, another thing we need to talk about is a common factor. When our a value is not 1, we always need to check for a common factor. So you can take out a common number and or variable. So like this example, we have 3x cubed minus 6x squared plus 27x. So we're seeing what do these three terms, which this is called a trinomial, right? Which do these three terms have in common? Let's first talk about the number. Do they have any numbers in common? Yes, they have a 3, so I'm going to take a 3 out. Do they have a variable in common? Yes, all of them have an x. And the least amount that I can take out is just an x, okay? So once we've done that, we do need to rewrite and put it in parentheses. So basically, I'm going to take everything and divide it. So we do 3 divided by 3, that gives me 1. And then x cubed divided by x, that gives me x squared. Okay, I do negative 6x squared divided by 3x. Well, negative 6 divided by 3 gives me negative 2, and x squared divided by x just gives me x. Then I do 27 divided by 3, that gives me 9, and then x divided by x, they just go away because they cancel. So this is what I'm left with, okay? So we will need to check that every single time. Now that means that all the terms have to have something in common. If only 2 have something in common, you can't take anything out. So be careful with that. Okay, let's go ahead and do our first one. So we have 5x squared minus 17x plus 6. So we're going to factor if it's possible, just like we did with the last section. Okay, first thing we need to ask yourself, is there anything that these three terms have in common? Is there a number that these three terms have in common? No, the only number they have in common is 1. What about a variable? Unfortunately, no. There's 2 terms that have a variable, but the last one does not. Okay, so now let's talk about how are we going to factor when there is an a value, or the a value is not 1. Well, we're going to use what is called a guess and check kind of method. So we are going to find the numbers that multiply to 6, so the factors. But we are also going to find the factors of our a value. Okay, now we do our 2 sets of parentheses here. Now, the thing is, if there's multiple pairs, we're going to go from the bottom of our list. If there's only one pair, you have to use that. So like with our 5, the 1 times 5, I have to use those values. Now, what I'm going to do is I'm going to put the 1x in one set of parentheses and the 5 in the other. So they don't go into the same set of parentheses, they go in different ones, right? And I have to put an x because remember, I'm trying to multiply to a 5x squared. So x times 5x does give me that. Now, as I said, if you have multiple pairs, start from the bottom. The idea is that we have to exhaust all of our possibilities, and if we do, then we can say this is non-factorable. Otherwise, then it is factorable. Okay, let's try 2 and 3. Okay, from here, what we're going to do is I'm going to multiply the inner and then multiply the outer terms. So 2 times 5x gives me 10x, and x times 3 gives me 3x. Now the whole idea is I'm trying to figure out, I want to add up to that negative 17x, that middle term. Well, if I look at 10x and 3x, will I ever add or subtract to it? No. So that means this does not work. And so my combination of where the 2 and 3 are at, that doesn't work as well. So there is going to be some erasing here, so you probably want to use a pencil instead of a pen here. Okay, so now we try 3 and 2. So I do 3 times 5x, that gives me 15x, and then x times 2, okay? Well, that actually does. If I do a negative 15x and a negative 2x, that will give me my middle term of negative 17x. Now, we need to decide where do the signs go. Well, your x's always stay positive. So the x and 5x, they will always stay positive. So that means we need to put the signs in between the two terms. Well, that means to get to a negative 15x, my 3 has to be negative. To get to a negative 2x, my 2 also has to be negative. So this is going to be my final factorization of my problem here. Okay, let's try the next one together as well. So first, determine with 3x squared plus 20x minus 7, do they have anything in common that we can take out? No, there's no number other than 1, and not all of the terms have an x, so we just keep it. So now we're going to find the numbers of our last term, numbers that multiply to it, the factors, which is 1 and 7. And then for our first one, it's going to be 1 and 3. So now we do 2 sets of parentheses. Remember, if you only have one pair, you've got to use that pair. So the 1 and the 3, we have to use that, and we're going to have x and 3x, because remember, when we multiply, that will give us 3x squared. Now, we have to use 1 and 7, because that's our only pair. So I'm going to put a 1 here and a 7 here. And let's see if this combination works. So I multiply the inner, 1 times 3x gives me 3x, and x times 7 gives me 7x. So the idea is I'm trying to add up to my 20x, okay? Well, 3x and 7x, that will never, if I add or subtract, give me 20x. So this combination does not work. So I'm going to erase, and I'm going to switch my values. And if that doesn't work, then we know this is non-factorable. Okay, 7 and 1. So I do 7 times 3x, that gives me 21x, and x times 1 gives me x. Well, if I add or subtract 21x and x, do I get my answer of 20x? Yes. So what I need to do is, because 20x is positive, my 21x has to be positive, but my x is going to be negative. Now, once again, the x and 3x, they got to stay positive because we never make the x's negative. So what's going to happen is, in between the x and 7, that's going to be positive, and then between the 3x and 1, that's going to be negative. So I'm going to just rewrite this so it looks a little bit pretty. So my final factorization here is going to be x plus 7 times 3x minus 1. Okay, I would like you guys to go ahead and pause the video and try the next example. Okay, let's see what you got here. So 3 is 1 and 3. My 7 is 1 and 7. So I do my 2 sets of parentheses. I definitely have to have x and 7x. Okay, we're trying to add up to a negative 20x. So let me try 1 and 3. And I multiply the inner, I get 7x. I multiply the outer, I get 3x. Well, 7x and 3x, if I add it, we'll never get to negative 20x. So that doesn't work. Now, some of you might be already can tell, like, the pattern, and that's fine. Right? Sometimes you can get, if once you see that pattern, it's a lot easier to factor these. Okay, now I'm going to try 3 and 1. So 3 times 7x gives me 21x, and then x times 1 just gives me x. I'm trying to add up to a negative 20x, so that means my larger number has to be negative. My larger number is 21. So that means I have to have x minus 3, and then 7x plus 1. So here's my final factorization. Okay, let's go ahead and try some more. I want you guys to go ahead and pause the video and try these 3 here. Okay, let's see what you got. So on here, once again, we have 1 and 3. We got 1 and 2. So I have x and 2x. Let's try 1 and 3. We're trying to add up to the middle term of just x. So 1 times 2x gives me 2x. X times 3 gives me 3x. Okay. Now I want to add up so it's 2a plus x. So my larger number needs to be positive. My smaller needs to be negative. Okay. So we have x minus 1 and then 2x plus 3. Now we still need to look at this because, yes, we were able to add up to the middle term. However, if we do negative 1 times a positive 3, will that multiply to our last term of a positive 3? No, it doesn't. Negative 1 times 3 gives us negative 3, not positive 3. So actually, this combination does not work. So we're going to go ahead and switch it and see what happens there. So I'm going to switch the 1 and the 3. So we're going to put 3, and we're going to put 1 here. So 3 times 2x gives me 6x, and x times 1 gives me x. Oh, that definitely will not add up to the middle term of just x. So this is because we exhausted all our possibilities. You cannot factor. Okay, let's try the next one. So we have 1 times 3, and then this one, 1 times 3. So that might help to make it easier. Okay. Now, also, when you were doing these, make sure you ask yourself, were we able to take anything out on these? We could not. Okay, so all of them did not have a number in common other than 1, and all of them did not have a variable in common. Okay, so we have a x and a 3x. Let's try 3 here and 1 here, okay? So I multiply the inner. 3 times 3x gives me 9, and x times 1 gives me x. Now I want to add up to a negative 10x, so that means both of my values have to be negative, because negative 9 minus 1, that actually gives me negative 10. So I do both negatives here, and if I do negative 3 times the negative 1, that does multiply to a positive 3. So we factored this correctly. So here's my final factorization. X minus 3 times 3x minus 1. So notice, kind of just going back as we did with our first section when a did equal 1, we are taking trinomials. Remember, trinomials means 3 terms, and we are factoring them to create 2 sets of binomials. Remember, binomials means 2 terms. Okay, last one. So with my 2, that's 1 and 2. With my 4, I have 1 and 4, 2 and 2. So we got to try both of these. Okay, so I tried 2x and 2x, and I tried 1 and 2 to see if this works. Okay, multiply the inner, I get 2x. Multiply the outer, I get 4x. I'm trying to add up to the middle term of negative 9x. Well, 4x and 2x, that will never add up to a negative 9x, so this doesn't work. Now the thing is, because my 2x and 2x, right, they are the same, I don't need to swap anything. Now here's the thing. For my 1 and 2, I have to use that because that's the only pair. So the thing that I'm going to change is my 2x and 2x, because that actually did not work. So instead of using 2x and 2x, I'm going to use 1x and 4x and see if that works. Okay, so we have 1 times 4x to give us 4x, and x times 2. Okay, once again, that doesn't help. So that doesn't add up to the negative 9x. So let's switch the 1 and the 4x. There we go. Okay, so here, oops, that should be, let me switch that back again. So it should be the 1x and the 4x. I'm just going to erase this whole thing to make it work better. Okay. So we are trying 4x and x, and we had 1 and 2. Okay, so in the middle I get x, 4x times 2 gives me 8x. Now I'm trying to add up to a negative 9. That means my x and negative 8, they have to be negatives, because negative 8 minus 1 gives me negative 9. So that means both of these are going to be positive. And I know if I multiply negative 1 times negative 2, that will give me positive 2. So I factor this correctly. Here we go. Okay, make sure you watch part 2. We're going to continue to factor quadratics when a does not equal 1.